Hello, my name is Jan Pöschko. I work as a kernel developer for Wolfram Research, and I'm mostly involved in all the cloud technologies. My talk will be introducing all these technologies and products, and we'll see how you can interact with cloud notebooks in the browser without any plugin or local installation of Mathematica, and take that further to deploy things to the cloud, either interactive content using notebook technology or arbitrary API functions and whole web applications that you can use on the web. Hi, my name is Jan Pöschko. I'm from Austria, but now based in the Wolfram headquarters in Champaign, Illinois, where I mostly work on the Wolfram Cloud and related technologies. And that's what I'm going to talk about here today. So when I say cloud, it's really a couple of technologies and products under one hood. And what are two very exciting ones that I want to talk about here today is notebooks in the cloud, but then also the cloud as a target for deployments to share and deploy your content. And we've seen some examples before in the introductory talks, but here I want to go into a bit more detail. So let's have a look at it and open up the Wolfram Cloud. So what you can see here is already a few thumbnails for products that we'll introduce in the next time. So here you see Mathematica Online, which is focused on the notebook interface, and it will work very similarly to the desktop product, where you do evaluations and you care about the notebook mostly. But then there's also the Programming Cloud, which will probably introduce first, and this will also have a notebook interface, but it will also allow you to do all sorts of deployments from the cloud into the cloud, but also from desktop Mathematica to the cloud if you want. And then there are more products upcoming, like the data science platform, the discovery platform, but those will come at a later stage, and probably even many more products that will be based upon this cloud technology. So let's look at the Programming Cloud. You open it up. I'm already logged in, and then I get this dashboard. You have your files over here. So with your cloud subscription, you get your space inside the cloud that you're free to manage in this file explorer. And of course, you can create new notebooks here. So let's see how that works. So this is very similar to desktop notebooks. You can just type in this area, do evaluations. It will make a trip to the cloud server, come back with the result, and display it. You can type text in here. As usual, you can style it if you want. You can add sections and subsections. Very similarly to the way desktop Mathematica works. And it's really important to realize that this is all running in the browser, so there's no plugin connected to this, and of course it doesn't rely on any local desktop Mathematica installation, all in the browser. So title, and so of course it took a lot of effort to replicate all this functionality, and we particularly spent a lot of time replicating the auto-completion and code assist features of the front end, and also introducing many features that are new in version 10. So you can see that while I type here, I get these suggestions, and they're quite intelligent. So it realizes that plot is a very likely to be used symbol, so it suggests that. And when I select it, I can get to another drop-down that suggests different forms of plot. There's function signatures or function templates. So I can simply select one of these, then fill in the templates, the slots, like this. You can also see that you get nice syntax coloring here, so the local variable is colored differently from the global system symbols, get auto spacing, and so on. So it's really quite a sophisticated editor right in the web browser. Of course, we can evaluate this and get back a nice plot. And this is not just a static image, actually. I mean, it is using an image in the background is actually a vector graphics. And so I can go and select it and resize it. It will go back to the server, make some minor adjustments, but basically it just works. You also see the predictive interface or the suggestions bar down here, which is, I think, pretty useful for newcomers to the language, but also if you don't remember all the options to certain functions. So we can use that to add a filling to our plot, for example. And this all works quite nicely. So that's 2D graphics, basically. Of course, there are also 3D graphics. Let me just, hold on. Grab an expression from over here, and of course I can copy and paste that from Desktop Mathematica and do this 3D plot. Again, I get back a nice image first that actually uses a desktop sort of front end in our server infrastructure to render this image. But then as soon as I click this and drag around the mouse, it will immediately switch to quite a sophisticated WebGL-based implementation of 3D graphics inside the browser in JavaScript. And so this is actually quite seamless, and I can rotate this 3D graphics here, let go, and it will switch back to the image that also shows the coordinate labels, for example. So right, that's very simple 3D graphics. I mean, done very easily right in the browser, which is, I think, pretty cool. Of course, Mathematica wouldn't work without Manipulate. So let's try that in the Wolfram language on the cloud. And let's say we just manipulate the limit for the y coordinate. We evaluate this, and eventually we'll get back this familiar manipulate interface with the slider that I can just drag, and it will update and give me the new 3D graphics. Again, just running in the browser, of course. So if you think about using cloud notebooks to construct interfaces and interactive content, then you probably also care about all sorts of controls that the front end provides, and that we're steadily implementing in the cloud front end as well. So, and one very important instance of these is dynamic, of course. So you can have dynamic of x, and then as soon as I assign a value to x over here, it will update the value up there. So very familiar and simple things in the Wolfram language, of course, but inside a browser, that's really neat and quite unique, actually, to have such a dynamic interface construction. We can take this a little further and create an input field for this dynamic value, and as soon as I change it down here, it will update up here, or if I make an assignment, it updates both, of course. So that's just a few controls. Of course, there are many more. Let me see. Let me just copy and paste this. Oops. Sorry. So you can see that all these controls like sliders, input field, buttons, tab view, and so on, they basically all work in the cloud. I mean, it's a big challenge, of course, quite an ambitious project to implement all these things in the browser, and so not every little option of every little control will work, but I think we're already at a very good state, and we have a very solid framework to implement many more of the desktop front-end features in the cloud as well. And the challenge is not even so much the interactive controls, but it's really at a lower level in terms of typesetting. So one example that's quite tricky to implement in a browser is something like this, where you enter or you get back a very large number from a computation, and of course you expect it to line wrap nicely and to introduce little spaces between digit groups. And so none of this is provided by the browser. If you know HTML and CSS and so on, there's just no way to do that. So we had to start at a much lower level and basically taking care of measuring and placing individual characters in the browser exactly where we want them to be. So we're not using HTML at a very high level, but really at a very low level and build on that to get sophisticated typesetting. So things like formulae actually look pretty good already. I used X before. So we have something like this. I mean, there are a few glitches. You can see the line wrapping is not completely perfect yet. Some of the parentheses are a little too large. Actually, that's already fixed. It's just not deployed to our servers yet. So there are a few things we can still improve here, but in general, I think this is pretty useful already, and quite good to have that in the browser. So right, that's about cloud notebooks. Now, what can you do with this? I already mentioned that with your cloud subscription, you get your space in the cloud, and you're free to upload files there, to create and manage the files. Can not only be notebooks, but also images, text files, and so on. You can either do that inside the cloud interface, but if you have a version of Desktop Mathematica, at least for version 10, there's also a very nice integration from there to the cloud. So let's just open a notebook that I had before, and now in the file menu, wait a second. Now this is actually wrong. Let me restart this. I have to sign in first. That's not. I don't know why that button isn't working. Okay, I don't know why that's grayed out here, but usually you would be able to just take that notebook and save it to the Wolfram Cloud. It would bring up a little dialog, and you could transfer your files from Desktop Mathematica right into the cloud and then open them there. And then once you are in the cloud, and we can easily do that with this notebook as well, you can use the cloud to share your content with others, of course. That's the big benefit of this whole technology. So under File Access, you can choose to either make this notebook completely public so that anyone with the link can access it, or you can share it with individual collaborators. And they will get an invite by email, and then they will be able to either just view the file or even edit the file if you let them. So right, that's about using cloud notebooks and collaboration and so on. Let's go on with the slides. So, of course, it wouldn't be the Wolfram language if there wasn't some programmatic way to do all of this and to access the cloud. And so what we're introducing with the new version of the language is a thing called Cloud Object. It's basically a handle to a file or some object in the Wolfram Cloud. So if you evaluate Cloud Object, okay. Now something is very weird. I don't know why that happened. Let's try again. Okay, that's, sorry, that's very unfortunate. So that seems to be some problem with my local kernel. Maybe we can't do these things. I mean, maybe I can't evaluate these things right now. Shouldn't debug this right now. So let's just have a look. Sorry. So what this would give you is you evaluate cloud object of my file, and it normalizes to the URL to something like this, where you have a URL in the cloud and a handle to your file inside your user account. Then what you can do is you can use that cloud object handle like an ordinary file, and for example execute put on it. Put takes an expression and a file name, but instead of a file name, you just use a cloud object in this case. And I did that before, so it should still be there. Then if you click the link, you get a website in the Wolfram Cloud, and it just displays the expression in this case. It also works the other way around, so if you do a get on this cloud object, it will just grab back the contents. And we overloaded all sorts of file-related functions to work with cloud objects. One special case are unnamed cloud objects. So you might not really care about the name, the file name of your cloud object. You just want to deploy something to the cloud and get back a URL automatically. And this is what this is for. So cloud object of no arguments will just evaluate to something that involves a UUID in this object's space. And actually every cloud object has a UUID and it can be uniquely identified, but sometimes it's hidden behind the file name. And then there's a shortcut to several functions that access the cloud. For example, for put, there's cloud put, and if you just give it an expression, it will construct an unnamed cloud object on the fly and give you back the URL. That's particularly useful if you have some big data, let's say, and you want to put it in the cloud and then share it with others. You put it there and then share the URL. And others can just execute get on the cloud object, get back the expression. And what you would do to actually share with others is you would set the permissions. So by default, everything will be private, but you can also say when you, let's say, cloud put something, you set the permissions for some other user identified by their email address to be read access. So they won't be able to change it, but read from that object. Now, we can take this even further and not only put static content into the cloud, but also active content, so to say. And a very useful case is, of course, manipulate. So we use the function cloud deploy to create something that's active in the cloud, as opposed to just a plain expression. So if you cloud deploy and manipulate, we get back this cloud object, and should be able to go there, and we have the manipulate. But even cooler is now that we can use this cloud-based manipulate to embed it anywhere else we might want it to have. It's not too hard to come up with that yourself, but there is a convenience function called embed code that produces this iframe code for you, and already created some very simple website that includes this iframe. So if we go there, it loads the manipulate from the Wolfram Cloud, and here you can interact with it as usual. So this, I think, is very useful to get interactive content on other websites without needing a plugin or anything. It will just work. Right, so that's about cloud objects. I said there's interactive content or active content in the first place, and a lower level compared to manipulate is probably an API. So if you have some Wolfram language code that you want others to access, and that might be used programmatically on another website or anywhere else that can access the web, you're really thinking about a programming interface, an API. So there are two ways to do this in the Wolfram Cloud. You can either, in both cases, you start with some function let's say this simple function that factors an integer. If we create a new notebook in the programming cloud and execute this, we now have this deploy menu, and we can choose to deploy whatever definitions we have in our session as an instant API. It brings up this interface, and here we can simply choose the symbol F, add it to our list of API methods. It will automatically figure out, it's not quite optimized to that screen resolution, I see. But it will automatically figure out that there's a parameter called n, it should be a number, and yeah, that's what it will use. Eventually we'll hit publish, and we get back, again, a cloud object URL. So if we go to that location, first of all, it will complain because we have this parameter n, and it's mandatory, but we didn't enter it. So we get this nice form where we can enter a number. And as soon as I resend the request, it will just change the URL and come back with the result from the computation, all in the cloud. I can also change the parameter over here, of course. And so I have this programmatic interface to Wolfram language code. Now, by default, this is displayed in Wolfram language format, but you could imagine that you might want to have it in some other format, and of course, the Wolfram language is very good about exporting and importing various formats. So if you just say export form goes to JSON here, you get a nice JSON output for your lists from the API function. Right, so we've seen the deploy menu, but of course there's also a way to do that right in the language without using a GUI at all. And the magic symbol in use here is API function, which is a wrapper around the function we had before, but in addition it sets up this mapping from parameter names to variables that you can use in here, setting up types and so on. And so that's the same thing. It's deployed, so we can use it the same way. Now, as soon as you have an API function in the cloud, there are all sorts of interesting things you can do with it, of course. You can literally embed it anywhere. And similarly to the HTML embedding, we provide some helper code for you to create all the boilerplate that's necessary to call an API in the cloud from other languages. So if you have, let's say, Java, you just execute embed code of your cloud object to Java, and it will produce all this code that you can copy and paste into your project. Many environments and languages have been implemented already. That's the current list. But this will certainly grow, and maybe can even be some community-driven effort to add more to this list. Right. So the idea is you have some APIs in the cloud and call them from anywhere, and then the cloud will really take care of the rest. So it has to scale anyway, so it will just use as many kernels as necessary to serve all the requests that come in for your API functions. And the way it's built is basically per use. So you just pay for the microseconds that the kernel spends evaluating your API functions. That's what it uses cloud credits for that you can buy. You get some initial amount of cloud credits when you sign up for the programming cloud, and then you can buy more, of course. So right, that's the idea about that. Now, that's a very rather low-level programmatic interface to interact with computations in the cloud. But if you cater to human beings, you rather want them to interact with some nicer forms, probably. And there's a friend to API function called form function. It works very similarly. It takes some named arguments and a function to execute. And if you do that and go to the resulting cloud object, it will present you with a nice form where, again, you just enter your values and get back the result. Now this could, we said before, you could export this in all sorts of ways, so you could also return an image from this form, for example, to have something more nicer looking. And because it's a Wolfram language, it doesn't only know about integers and primitive types, but for example, a city is a first class type in this specification. So you can say you have a form that takes 2 cities as parameters and then creates a geoplot of those 2 cities. So if we go to that form and enter, 2 cities, we submit, and geographics sometime take a little while to come back because it has to make a trip to the map server. But I hope. Okay, that's a bit unfortunate. Sorry about that. So you can, it's a map, right? It's maybe from higher above, so the landscape is covered by the clouds, unfortunately. But you can see the 2 dots of London and Frankfurt at least. Right. So yeah, that's about form functions. Now this can get arbitrarily sophisticated. So I want to show you a quick example of how you can do real full-scale web applications using the Wolfram Cloud. And anything beyond a simple form would probably require some more coding, and that's what this is about. So the idea is we will create a simple application for a traveling salesperson where users can click on a map to define locations and will on the fly compute the shortest round trip through all of them. As a little extra, also show an elevation plot and also persist the trips. So that's something you obviously want to have in web applications. It's not a one-off evaluation. You really want to be able to also persist data on your server. And so this is where all this technology sort of comes together. It starts with very simple definitions in the Wolfram language, of course, where it's very easy to compute the distance between two locations on Earth. So we can define this function. Then finding the shortest tour for a given set of points is also very easy with that distance function. And also getting the elevation for some location on Earth, very straightforward. Then I said we want to persist data somehow, and that's what we'll use a cloud object for. So we basically want to store a list of the trips a user created so far. And the way we do this is we just use a cloud file called TSP data, and then there's this convenience wrapper cloud symbol around cloud object or a plain string. And if you assign something to it, it will just automatically put it into the cloud. So that's a neat way to initialize this data. Then another thing comes in very handy here, which are templates. That's something you regularly use in web development. You have some HTML template and you fill it with data. So this is where file template comes in handy. I won't show the details of this, but it's basically a template that has some slots for various data and also some JavaScript to display the map and so on. And when we have these templates, we just create API functions as our active websites, basically. So the starting page just doesn't take any parameters, but when it runs, it applies the template to the data that comes from our trips cloud object, exported to JSON, and then after it applies that template, it just interprets that template as raw HTML so that the browser serves it, or the server serves it as an actual HTML page that the browser displays as such. Very similarly, the page for individual trips, they just take the ID of a trip and get the points in the trip, compute the tour, and then again fill in the template with the JSON data and export it to HTML. There's another page to add a trip, which just appends an empty list to the trips, and then displays the trip. Then we need two more little APIs, one to update an existing trip. There you can see that it's very straightforward to just pass in JSON data to an API function. It will be automatically parsed into a corresponding Wolfram language structure that you can use to compute the new tour and pass back JSON data again from our API function. And then another thing, just to illustrate that, here we have an API function that takes points as JSON, then does some computations, uses list line plot with some custom styling, but eventually it produces a PNG graphic that it just returns to the browser. And in the end, this is pretty much all we need for our server-side implementation for this web app. We just have to deploy it to the cloud, and that's just a bunch of cloud deploys, and you can easily imagine writing some script that does that for a more complex web app. So we just take the individual API functions, deploy them to particular URLs, and in the end, this is the URL for the index page. So, something went shortly wrong. Now it's there. So already had some trips from before, but this is the starting page. It allows me to add a trip. I don't exactly know what this is about, but some temporary glitch on the server, I guess. But now we can use this map to just add a few points. Let's see, here and here and here, maybe down here. And as I do that, it's constantly making AJAX requests to the server, getting the new trip, which is displayed here, also displaying this nice elevation plot down here using list line plot. I don't know, I could remove points also. Need updates, or we add one more here. And as I said, this is all persisted too. I mean, you saw it before. Here's the list of trips. So I can come back here, and if I refresh the page, often enough at least, it will show me the same trip again. So basically, we've used the whole stack to implement a web application based inside the Wolfram Cloud, using cloud objects as sort of a database, templates to render HTML and other things, and using API functions to serve content dynamically. And I mean, so far this might still seem like a rather low-level interface, but one could easily imagine that we build even higher-level abstractions of whole web applications, and it would be very easy to have a symbolic representation of a whole application and just deploy it to the web at once. I think that's a pretty interesting idea, and the way it works so nicely is, of course, because the language is symbolic in the first place, and it's easy to exchange data and code and just have a seamless interface between different systems and servers. Right. So that there are a few more things that will be possible with the cloud that I can just mention briefly. The idea is that we'll provide a free Wolfram language sandbox based on cloud technologies. So I think that will be very useful for newcomers to the language to just play around with it a little bit in a sandbox without having to install anything on their computer. Then we've mentioned report generation has come up before. It will also work in the cloud, of course, for certain tiers and subscriptions at least. And another very interesting idea is private clouds. So especially if you have some data that you feel uncomfortable putting in the general cloud, you might want to consider going for a private cloud, which could either be a dedicated area inside the Wolfram Cloud or shipped as a virtual machine to be installed on any hardware and infrastructure you want. And that would also allow you to include other arbitrary external libraries for your code or do other customizations that we just can't allow for security reasons in the general Wolfram Cloud. Those are under construction still, but will be available also rather soon, I hope. Right, so quick summary, we've seen cloud notebooks, what you can do with them. They offer a lot of desktop-like behavior right in the browser. There's some things still left to do for us, but it's in pretty good shape already, and I think very, very useful already. This whole cloud technology allows you to easily share notebooks, but also code and data with others. And it's also seamlessly integrated into both Desktop Mathematica and the Wolfram language itself. It allows you to easily inject computation basically anywhere where you can access the internet using API functions, form functions, and so on. And we've seen that it's quite straightforward to deploy simple web forms or even whole web applications using cloud technology. As I said, this is a huge effort, of course, and there's still some things we have to polish, but exclusively for you, you will be able to access it at this early stage. So if you go to wolframcloud.com/access and enter this invitation code here, you'll be able to create an account and start playing around with this technology. You'll probably find some issues, but many things will work, and it will be very interesting for us to find out what you want to do with this and take it from there. So, right, thank you very much for your attention, and hope to see you in the cloud.